Yeah, good morning, my beloved audience. How are you people doing? I hope we had a beautiful night rest. Thank God for a beautiful day like this. So today we'll be looking at some basic concepts in mathematics. We will be taking questions from various topics, then analyzing it gradually. So the first this we're going to look at is arithmetic progression. That's what we call AP, arithmetic progression. There are about 3 or 2 basic things we need to know concerning arithmetic progression. The nth term of an arithmetic progression and the sum of the first nth term. Okay, so in a nutshell, the nth term is given as a plus bracket n minus 1d, where a is the fourth term of the arithmetic progression, n is the number of terms, then d is the common difference. If tomorrow you want to look for the first term, t1, means this will be a plus, here will be 1 minus 1, d. But here, 1 minus 1 is 0, and 0 times will be 0. So t1, the first term is equals to a. So a stands for the first term of an arithmetic progression. Then, to get the second term, your n becomes 2. So this will be a plus 2 minus 1 is 1. 1 times d will be d. To get t3, that will be a plus 3. 3 minus 1 is 2. 2 times will be 2d. To get t4, that will be a plus 4 minus 1, that will be 3d. If you want to get maybe t10, you'll be a plus 10 minus 1, 9d. Then what do we notice? We notice that the coefficient of the, because here is 9, here is 10, here is 3, but here is 4, here is 2, here is what? 3. So which means the coefficient of d is always 1 less than the number of terms. The coefficient of d, this 3, is always 1 less than the number of terms. Now let us take an example. Let's take an example. If the first term of an AP is 28 and the common difference is 9, find the maybe fifth term. Find the fifth term. So when you get maybe T1, T2, T3, T4, T5, yeah, this is A. To get the next term, you add the common difference, which is D. That will be A plus D again, A plus 2D, A plus 3D, A plus 4D, and this is the one we're using. They call it, this is the what? The fifth term. So in that case, let's look at it together. If the first term of an AP is 28, that means our A is 28. And the common difference is 9. That means D is equals to 9. They say find the fifth term. Fifth term is this one. So T5 will be equals to A plus 4D. So wherever I see A, I'll substitute 28. If I see D, I'll substitute 9. So this will be T5 equals to 28 plus 4 into D. D is what? 9. So this will give us 28 plus 4 times 9 is 36. Then I'll now take this and add with this. That will be 64 because 28 plus 36. 6 plus 8 plus 6 is 14. So write 4 and carry 1. 1 plus 2 is 3, and 3 plus 3 will be 6. This is a 64. That shows that the fifth term is 64. Now, proof. The first term is 28. The common difference is 9. So if we add 9 to this 28, we'll get 37. This 37 will add 9 to 37. We are going to get 46. You add 9 again to this one. You add 9 here, you get 55 plus another 9. You get what? 64. So which means this is the first term, this is the second term, this is the third term, this is the fourth term, then this is the fifth term, this one, which is this one here. Yes, that means, which means it's an arithmetic progression. So since the first term is 28, the common difference is 9. That means if I add 9 to 28, I'll get the next term, yes, which is what? 37. If I add 9 to 37, I'll get the next term, which is 46. If I add 9 to 46, I'll get the next term, which is 55. If I add 9 to 55, I'll get the next term, which is 64. So what they are trying to say is that since the first term is 28 and the common difference is 9, that if we continue doing this thing like that, the fifth term is going to be what? 64. Because the first term already is 28. From 28, you followed by what? 37. Yes, from 37 followed by what? 46. From 46 followed by 55. From 55 followed by what? 64. Even from 64 followed by what? 73. 73 will be the sixth term. From 73 again, you can get what? The seventh term, and so on and so forth. Okay, so that is that. Then the next thing we want to look at now is this arithmetic mean. Arithmetic mean. Arithmetic mean. There, before we continue, please, I'll be the way you can encourage me doing this thing. You click on the subscriber button. You follow me so that whenever I'll be live, because I'll still be live again in the evening. In the evening, we'll be doing maybe chemistry and physics. So when I'm live, then you get the notification immediately. So also like my videos, then comment. Wherever you are having some challenges, please you drop it on the comment section. Then if there are some topics also you don't understand, not just mathematics, biology, chemistry, physics, maths, further maths, you also drop it on the comment section. Then I will, maybe in the evening, I may do video concerning that. So let's proceed. So I want to look at arithmetic mean. Arithmetic mean is just like the ordinary mean we know it comes in statistics, what we call measure of central tendency or measure of central location. Oh, we are talking about mean, mode, and median. Yeah, so the arithmetic mean here is just average, which is like sum all of a number. Now, what happened is that somebody we may have a question like this, maybe. If we have maybe find x if 5x 11 are in a AP. If these things are in AP, that means this is T1, this is T2, and this is T3. The first term, the second term, and the third term. Now, if they are in AP, for me to just get x will just be 5 plus 11 divided by 2, because they are talking of mean, average, sum of a number. So this will be 16 over 2, which is what? 8. So therefore, the AP is 5, 8, 11, because 8 minus 5 will give us 3. This minus this will be the same as this minus this, and 11 minus 8 will also give us 3. So that is the distance. So the answer is what? This 8. So then, find x comma y in the AP. 5. 9. That's 4. So we have that one. Find x, comma y. Find the values of x and y in the arithmetic progression. This one is also very simple. What do we do? Solution. We just take, this is 5x, comma y, comma 17. This is my first term, a. Then this one will be what? A plus d. I add another d. This will be what? A plus 2d plus d again. A plus 3d. Very simple. So from here, the first term a is 5. So a is equals to 5. I'm taking this one. I'm also taking this one because I know them already. I don't know this one, so I'll leave them. I'll deal only with this one I know. A is 5. Then this one, a plus 3d is 17. A plus 3d is equals to 17. So what I'll do now is that in the place of a, I'll substitute 5. Because since there are two unknowns here, you cannot use one equation, yes, to get two unknowns. Number of unknowns must be equal to number of equations. So in the place of a, I'll substitute 5. So this will be 5 plus 3d equals to 17. So this will give me 3d equals to 17. This is plus 5 on the left-hand side. You take it to the right-hand side, minus 5. Then this will be 3d equals to 17 minus 5 is 12. So from there, I'll divide here by 3. Then I'll divide here by 3. So d is equals to what? 4. So from there, I can now, the common divisor, so which means x will be equals to what? A is what? That's 5 plus d. D is what? 4. So x is equals to 9. Then y is a plus 2d, which a is what? A is 5. D is 4. So 4 times 2 is 8, which will be 13. So in that case, this guy is 9, and this guy is what? 13. So it is 5, 9, 13, 17, which is this minus this will give you 4. This minus this will give you 4. This minus this will give you 4. So these are the two answers. Then there is now a modern way examiners now ask questions concerning arithmetic mean. They don't go this way. There's a pattern they go now for you to know whether you actually know that concept of what arithmetic mean is all about. Let's take a look. If the arithmetic mean of A, B, C, D, E is 60, and that of A, B, C, D, E, X, Y, and Z is 8. Okay. 8. Okay, that will be 1, 2, 3, 4, 5, 6, 7, 8. 96 is 12, comma. Find the arithmetic mean of X, Y, and Z. So can I have a question like this? Yes. If the arithmetic mean of A, B, C, D, and E is what? 60. Now, arithmetic mean of what? A, B, C, D, E. That means I will take A plus B plus C plus D plus E divided by 5. I'll get yes. The arithmetic meaning of that is that 60. No, let me put it to be, no, 60 is big. Let's use it to be 12. Let's use it to be 12. So which means for me, I'll get A plus B plus C plus D plus E divided by 1, 2, 3, 4, 5. Because mean simply means sum over number. So add or divide by 1, 2, 3, 4, 5. This is a 5. So the mean is 12. So this is a fraction. I can make this one a fraction by dividing it by 1. Then I'll cross multiply. 1 times this will be A plus B plus C plus D plus E. So 5 times 12 will give me what? 60. So that means the sum of all this is 60. So 60 divided by 5, I'll get 12. Then they said, and that of what? And that of, this word, that of, that means the arithmetic mean of these ones. So which will be, let's do, I'll add these ones. A plus B plus C, I'll add all these ones. Plus D plus E plus X plus Y plus Z divided by 1, 2, 3, 4, 5, 6, 7, 8 divided by 8 is equals to 12 over 1. So I'll now cross multiply. But before doing the cross multiplication, this one up to here, this one's here. It is this one. That's this one. Is this. So wherever I see A plus B plus C plus D plus E, I'll put 60 because A plus B plus C plus D plus E is this one. So the whole of this one. So which means this is 60 plus X plus Y plus Z. This will be equals to 8 times 2 is 16, carry 1. 8 times 1, 8 plus 1, 9. So from there, I will now get X plus Y plus Z will be 96. This is 60. Take it the other side. Minus 36. So X plus Y plus Z will be, this minus this is 0. This minus this is this. Okay, yes, that is, am I right? 6 minus this is 0. 9 minus 3 is 60. Then now, this one is the sum of what? X, Y, and Z. But they said I should look for what? Find the arithmetic mean. Mean means I'll divide. That means this will be X plus Y plus Z divided by 3, which is 60 divided by 3. So therefore, it is 20. So the mean of X, Y, and Z is 20. But the sum of X, Y, and Z is 60. So please ensure that you subscribe, you like you like my videos. If you go, you see videos I've made in physics, chemistry, and so on and so forth. You go through them. Then if I thought maybe you have some issues why I'm explaining this thing, you can drop your question on the comment section. Then later I'm going to maybe attend to it. So let's proceed. So the next thing we're going to look now is that AP can result to simultaneous equation. Simultaneous equations are 2 or more equations that are solved at the same time. One cannot be solved without the other. So AP can result to simultaneous equations. So let's look at it. So AP leading to simultaneous. AP leading to simultaneous equations. Example. If the fourth term of an AP is 9 and the sixth term is 13, comma, find the common difference first term. So that's the question we have. If the fourth term of an AP is 9 and the sixth term is 13, find the common difference and first term. The common difference actually is D and the first term is A. Now the word fourth term is what? A plus 3D is equals to what? 9. Because the coefficient of D must be 1 less than the number of them. So this is equation 1. And the question says there, and the sixth term will be what? A plus 5D is equals to 13. This will be equation 2 because the coefficient of D must be 1 less than the number of them. And this is a pair of simultaneous equations. And simultaneous equations are 2 or more equations that are being solved at the same time. One cannot be solved without the other. So now what happened is that we have about 3 methods of solving simultaneous equation. Method of elimination, method of substitution, and an outdated method known as the graphical method. But the best method used in solving simultaneous equation is method of elimination. And before you use method of elimination, one of the conditions in Dick-Quanum for you to use method of elimination is that the coefficients of one of the unknown supposed to be the same. If the coefficient of one of the unknown is the same, that one is a necessary condition. We have what we call necessary and sufficient condition. The necessary condition is that the coefficient of one of the unknowns must be the same. When it is the same, then this sufficient condition that you check their signs of those coefficients that are the same. If the signs are also the same, then you subtract. But if the signs are different, then we are going to add. So let's look at it. Here, the coefficient of 3 is what? Of D is 3. The coefficient of D is 5. No, I cannot eliminate D. I check this one. The coefficient of D is what? 1. And the coefficient of A is 1. And the coefficient of A also is 1. And the signs are the same, so I will subtract or put minus. Now, if you watch this equation, because many students always are fond of saying A minus A, 0, 3D minus 2D minus 2D. They'll do it like this. A minus A is 0, 3D minus 5D is minus 2D. Then they'll say 9 minus 13 minus 4. You are wasting time doing that. Since equation 2 is bigger than equation 1, take equation 2 minus equation 1 or subtract equation 1 from equation 2. This is how you do it. From here, A minus A is 0. 5D minus 3D is 2D. 13 minus 9 is 4. You don't have business with negative sign. Now I'm looking for D. What is disturbing D is 2. What is 2 doing here? Multiplying. What's the opposite of multiplication? Division. And we mathematicians, we don't believe on cheating. What you do on the left hand side, you also do it on the right hand side. So you divide here by 2. Divided by 2. So this cancels this. So D is equals to 4 divided by 2 is 2. So A is equals to 2. The common difference is 2. So I've gotten this one. Then to get this one now. So I'll now take maybe from equation 1, maybe this one. A plus 3D is equals to 9. Wherever I see D, I'll substitute 2. So this will be A plus 3 into 2 equals to 9. So here will be A plus 3 times 2 is what? 6 equals to 9. Then I want to get A. So I'll now bring this. Then I'll bring down this 9. Then this is plus 6 on the left hand side. I'll take it to the right hand side. That's minus 6. So A will be equals to what? 3. So I've also got this one. So then another question is that is it a must that I will substitute bed in equation 1? No. I can still use equation 2. That will be A plus 5D equals to 13. Here will be A plus 5 times 2 equals to 13. So here will be A plus 10 equals to 13. So you see here that A will be equals to 13. This is plus 10. I'll take it to the other side, minus 10. So A will be equals to what? 3. So therefore, the common difference is 2, but the first term is what? 3. Okay, so I think we are through with this one. Just get a few seconds so that we can go through it. And then the next thing we're going to look at now is sum of an AP, sum of the first term, n term of an arithmetic progression. Sum of the first nth terms of an AP. And so it is given by 1 Sn equals to n over 2 into A plus L. Yes, we'll use this one. We can use this formula when you know the first term, you know the last term, and the number of times, but you don't have any information about the common difference. That's when you can use this formula. For example, e.g., if the first and last terms of an AP are 3 and 37 respectively, find the sum of the first 6 terms. Find the sum of the first 6 terms. Now, if you look at the question, they have given us the first term. They have given us the last term. They have given us the number of term, n is 6. But they never said any information about the common difference. So you don't need to stress yourself. This formula is for you. Very simple. So, solution. So if the first term is 3, the first term is 3, so A is equals to 3. And the last term, L, is 37. They say find the sum of the first 6 terms, so n is 6. So now the formula will be Sn equals to n over 2 into A plus L. So this is our formula. So wherever we see A, we'll write 3. You see L will be what? 37. Then n will be what? 6. So this will be sum of n is 6 equals to 6 over 2 into 3 plus 37. That will give us sum of the first 6 terms to be equals to 6 divided by 2 will be 3 into 3 plus 37 will be 40. And sum of the first 6 terms will be 3 times 0 is 0, 3 times 4 is 12. And that's the answer. So this is the answer to the question. Okay, so this you get this from grade 10, grade 11, grade 12. Yes, grade 10, grade 11, grade 12. This topic is for them. And even those in the university in the first year, or someone in the university college. Yes, yes, like first year in the university college, depending on your course. Yes, you get this. Those in grade 10, grade 11, grade 12. You take this. Even someone that is taking them O level, A level. This topic is also there. So it's like a more of a general topic. Yeah, so thank you for the compliment. I can see somebody telling me there, yes, that I'm very good at explaining things. Well, it's not by my power. We just give glory to God, because the Bible says in Proverbs chapter 1, verse 7, the fear of the Lord is the beginning of wisdom. That means anybody that doesn't fear God in this life, forget about wisdom. Wisdom coming from above. So with everything, thanks very much, but we return to God, not to me. So to God be the glory. He's the giver of wisdom. Thank you very much for that compliment. So then, please, so I'm attending to your question. Somebody have also asked, that is this for grade what? They said from grade 10, grade 11, grade 12. This is involved in their curriculum. Those also in year 1 in the university, they also talk about arithmetic progression. Then we'll go to geometric progression, but let us see a situation whereby the common difference is involved in the question. What do we do? From here, this guy, L is equals to A plus bracket N minus 1D. So sum of the first N term equals to N over 2 into A plus L. So wherever this L is this L. So wherever I see L, what I'll write is what? A plus bracket N. So this will be N over 2 into A plus L. What is L? This one is L, because the whole of this stands for L. So in the place of L, I'll write this thing. So this will be A plus bracket N minus 1D. So this will be sum of the first N term equals to N over 2 into 1A plus 1A will be 2A plus bracket N minus 1D. So this is the formula. So this is the one where, yes, we are formally known with. But I mean, most time in the exam period, at times, they'll give a question whereby you need this. Yes, that you will be struggling to get the D. You cannot get the D, because when you use L equals to A plus bracket N minus 1D, where you have A to be 20, A is 3, and L is what? 37. Now you have known this one, but you don't know this, you don't know this. So it becomes a very difficult situation, because you cannot look for two unknowns in one equation. No. You cannot look for two unknowns. Two things here, we don't know it. So you cannot use that one. Yes, you cannot look for two unknowns in one equation. The number of number of unknowns must be equal to number of equations. So that's why when it comes to simultaneous equations, somebody will come and give you something like maybe 2x plus y is equals to 5. Maybe x plus y is equals to 3. Yeah, there are two unknowns here. Yeah, so that's why we have two equations. And when you solve this one, you see that x will be equals to 2 and y will be equals to 1. Because here, if you put here 2 plus 1 will give you 3. And here, 2 times 2 plus 1 will be 4 plus 1, which is what? 5, which is this 5. Yeah, so the number of unknowns must be the same as the number of equations. Okay, so let's look at an example. So Given that the first term and common difference, the first term and common difference of an AP are 25 and 8 respectively, comma, find the sum of the first 4 terms. So that's the question. So that given that the first term and common difference of an AP are 25 and 8 respectively, find the sum of the first 4 terms. So any question that involves calculation, what you do is that when you read the question, you bring out the parameters. So solution, the first term is 25. So A is equals to 25. Then the common difference is 8. Because they say respectively, that means in that order, that means this one is this one and this one is this one. So the common difference is 8. And so you should find the sum of the first 4 terms. So from here, we will now get sum of the first n term equals to n over 2 into 2a plus bracket n minus 1d. So what am I going to do? Wherever we see a, we'll substitute 25. If I see d, we'll substitute 8. If we see n, we'll substitute 4. So this will be, sum n will be what? 4. This will be equals to 4 over 2 into 2a. A is 25. Plus n is 4. So here will be what? 4 minus 1. And 4 minus 1 will be 3. D is 8. So this will give me sum of the first 4 terms. 4 divided by 2 give me 2 into 2 times 25 will be 50. 3 times 8 is 24. So this will give me 2 into 50 plus 24, that will be 74. Sum of the first 4 terms. 2 times 4 is 8. 2 times 7 is 14. And that is the answer. This is the answer to the question. Then you can also try to prove. Yes, you can also try to prove to know the listen. So proof. The first term is 25. The common difference is 8. Remember, I told you you have A is 8, 25. If this is the this in there, so this is T1. If I want to get the second term, I'll take 25 and add it with 8, which is 33. If I want to get the third term, I'll take 33 plus 8, which is 41. If I want to get the fourth term, it will be 41 plus 8, which is what? 49. Add this also. So this is T1. So my T2, that will be 33. My T3, that will be 41. My T4, that will be 49. So let's add it. Sum. 9 plus 1 is 10. 10 plus 3, 13. 13 plus 5 will be 18. Carry 1. 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4, 10. 10 plus 4 is 14. So that's the proof to show that this is the correct answer. I'm very good at explaining things. I am so you're very good at explaining things. Okay, please, I think we are through with arithmetic progression. So let's move to geometric progression. So now, actually, we're moving to so that's geometric progression. We'll call it GP. Yes, geometric progression, GP. So in the case of geometric progression, now we'll be talking about common ratio, not common difference. AP is all about addition. Yes, the AP is all about addition. And so that's why we talk of common difference. And in AP, we subtract. But GP is all about multiplication. And the opposite of multiplication is what? Division. So if it is AP is all about addition. AP is all about addition. So that's why we use D, which means common difference. But GP is all about multiplication. GP is all about multiplication. So that's why we use our common. So I think the first thing here is the nth term. The nth term of a GP. Yes, so the nth term, so Tn is equals to AR to the power n minus 1. So this is the formula for the nth term of a geometric progression T, where A is the first term, R stands for the common ratio, not common difference. Common difference is to AP, while common ratio is to GP. And to get common difference, we do subtract because AP is all about addition. Then to get common ratio, we divide because GP is all about multiplication. And the opposite of multiplication is division. So you subtract to get common difference, just as the name implies, difference. Difference means subtraction in mathematics. Then ratio means division in mathematics. So when somebody gives you something like A is to B, simply means A over B. That's what it means. So ratio, that's it. So from here, let me get the first term. N will be 1. Here will be AR to the power 1 minus 1. So therefore, the first term is equals to A. So the first term, to get the second term, 2. You put 2 here. That will be AR to the power 2 minus 1. That will be AR to the power 1. And any quantity raised to the power 1 remains the same. So here will just be AR. Then when you put 3, this will be AR to the power 3 minus 1 will be 2. Put 4. This will be AR to the power 4 minus 1 will be what? 3. T10 will be AR to the power 10 minus 1 will be what? 9. Then we notice something. What we notice is that the coefficient of what we notice is that the power of R is always 1 less than the term. So the power of R is 1 less than the number of them. So which means if someone talk of T40, you'll be AR to the power 39. The power of R is always 1 less than the term. Somebody talk of maybe something like maybe T50, it will be what? AR to the power 49. The power of R is always 1 less than what is here. So example, so if the first term and the common ratio of a GP are maybe 3 and 2 respectively, comma, find the sixth term. I have a question like this. So yeah, so the nth, okay, so no, if the first term and common ratio, so here the first term is 2, so solution. Okay, so A is the first term is 3, sorry. Then the common ratio is 2, so common ratio is equals to 2. They say find the sixth term, so n is equals to what? 6. So in that case we have now, well, sixth term simply means AR to the power 5 because the power of R will be 1 less than this one. So sixth term AR to the power 5. This is the system. So and that sixth term, this is so A is 3 times R is 2 to the power 5. So this will be 3 times 2 raised to the power 5 means I'll keep on multiplying 2 by itself 5 times. 2 times 2 is 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. And my answer will be 96 because it will be 32 times 3. 3 times 2 is 6. 3 times 3 is 9. So this is it. So this is, so therefore, this is the system. My own type of mathematics is that I will not just solve the mathematics, but let me prove to you, let me show you why this thing is 96. Why is it 96? Proof. According to the question, look at it. According to the question, the first term, this is T1. We have T2. We have T3, T4, T5, and T6. So here the first term here is A, and A is 3. That's it. So then the second term, to get the second term, it will be what? AR, which will be 3 times 2, which is 6. To get the next term again, this will be AR to the power 2, which will be 3 times 2 squared, which will be 3 times 4, which is 12. The next one here will be AR to the power 3, which is 3 times 2 is power 3, which is 3 times 8, which is 24. Then this guy will be AR to the power 4, which is 3 times 2 is power 4, which is 3 times 16, which is 48. Then this guy now is just 48 times, this is 3 times 2 to the power 5, which is the 3 times 32, which is 96. Or we can still, or you can just say the T6 is what? 48 times 2, you still give you 96. So that's the proof. So the next subhead we'll have is geometric mean. Geometric mean. Remember, we have done arithmetic mean. The arithmetic mean is to AP, while geometric mean is to GP. So you may have something like e.g. find x if maybe 2, x, 18 are in geometric progression. Here, now for us to get the value of x, 2x, they say they are in GP. Since they are in GP, x will just be equals to square root of 2 times 18, which is square root of 36, which is equals to what? 6. That's the answer. Because if you look at it, this will be what? 2, 6, 18. 6 divided by 2, this divided by this will be the same as this divided by this. 18 divided by 6, which is equals to 3. So that is that. So a liter or 2x6 x 18. This divided by this will be the same as this divided by this. So this divided by this, that will be x over 2. That's this divided by this will be the same as second divided by first will be the same as third divided by second. 18 over x. Then in that case, we can cross multiply. X times x will be x squared. 2 times 18 will be 36. So x will be equals to what? Square root of 36. So in that case, x will still be equals to 6, which is the same thing. In this one, they are the same. Please remember to subscribe on my channel so that when I will have the lesson in the evening, you get notified. So just you click on the subscribe button, you like the video, and also you share. I think that's the way you can support me. As you do that, may God bless you. So let's proceed. Then we'll have some of the first nth terms. Some of the first n terms of an AP, of a GP. So it is given by 1. Some of the first n term will be a into r to the power n minus 1, all over r minus 1. We use this formula when the common ratio is greater than 1. Then we can still get some of the first n term to be a into 1 minus r to the power n, all over 1 minus r. We use this one when the common ratio is less than 1. So let's take an example. E.g., if the first term of a GP, is 4, and the common ratio Common ratio is 2, comma. Find the sum. Find the sum of the first 5 terms. Yes. If the first term of a GP is 4 and the common ratio is 2, find the sum of the first 5 terms. So here, the first term is 4. The common ratio is 2. Find the sum of the first 5 terms. So in that case, the sum, since the common ratio is 2, 2 means is this one. Is yes, because 2 is greater than 1. So we'll use that one. So here will be a into r to the power n minus 1 all over r minus 1. And this will give us n. N is 5. A is 4 into r is 2 raised to the power 5 minus 1. 4 r is 2 minus 1. So this will give us, now is going to be 4 into 2 raised to the power 5 is 32 minus 1. All over 2 minus 1 is 1. This will be 4 into 32 minus 1 is 31. All over 1, which it doesn't mean. So the sum of the first 5 terms will be 4 times 1 will be what? 4. And 4 times 3 will be what? 12. And this is the answer. So the sum of the first 5, that means if the GP continues like that, if you add the first 5, what you get is 124. How? Let me prove it. The first term is 4. To get the next one, I'll multiply by the common ratio 2. So 4 times 2 is 8. 8 times 2, 16. 16 times 2 is 32. 32 times 2 is what? 64. When we add all this, what we'll get is 124. So let's add. This will be 64 plus 32 plus 16 plus 8 plus 4. 4 plus 2 is 8. And 4 plus 2 is 6. 6 plus 6 is 12. 12 plus 8, 20. 20 plus 4 is 24. You carry 2. So 2 plus 6 is 8. 8 plus 3 is 11. 11 plus 1 is 12. So this is it. Okay, now we have taken a yes, because the common ratio was greater than 1, that's why we use it. So for us to use this one, we'll take a question where the common ratio is less than 1. Find the sum of the first 6 terms of the GP or of the geometric series 128 plus 64 plus 32 plus something like that. This one is called a series, not a sequence. A sequence is a group of numbers that are being arranged in a particular order and they are what? Separated by commas, like this one. 64, 32. This one is called a geometric sequence. Yes. So it's different from this one. This one is geometric series. And what is a series? Series are terms in a sequence that have been added up together. Yeah, but they are still giving us the same information. But when you use that word series, you see either addition or subtraction there. So series are terms in a sequence that have been added up together, but it doesn't mean anything. You still give it the same answer. 128 plus 64 plus 32 plus. So here, the first term is 128. For me to get the common ratio, I'll take this and divide by this, or this divided by this divided by this. 64 over 128, which will be here. 64 can go here one time. 64 can go here two times, because 64 times 2. 2 times 4 is 8. 2 times this is 12. So it is that. So 64 divided here one time can divide here 2 times. And they say we should find the sum of n is 6. So n is equals to 6. So that will give me, so in that case, R is equals to 1 over 2, and it is less than 1. So since it is less than 1, I'm going to use the second formula. So sum of the first n term equals to a into 1 minus r to the power n, all over 1 minus r. So n is what? 6. So our a is 128. Yes. Into 1 minus 1 over 2 raised to the power 6. All over 1 minus r. R is half. So that will give us 128 into 1 minus 1 raised to the power 6 will be 1. 2 raised to the power 6 means 2 multiplied by itself 6 times. So 2 times 2 is 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. 32 times 2, 64. So this will be 64. All over 1 minus half will be half. That will give us sum of the first 6 terms to be equals to 128 into here. 64 times 1 is 64. 64 minus 1, that will be 63 over 64 divided by half. So this will give us sum of the first 6 terms is going to give us 128 times 63 over 64. This one is on the denominator. So when you multiply it, it will somersault. That will be 2 over 1. So from here, we can now divide. 128 divided by 64 is going to be 2, because 64 times 2 is 128. So 64 divided 1 time, 64 divided 2 times. So I'm now left with 2 times 63 times 2. So 2 times 3 is 6. 2 times 6 is 12 times 2. Sum of the first 6 terms. Yes, that will be 6 times 2 times 6 is 12, carry 1. 2 times 6 is 12, carry 1. Then 2 times 12 is 24 plus 1, then plus 1. So that's that. So the answer is going to be 252. Somehow we can get the proof here. Proof. The first term is 128. If you divide this by 2, you get this one, which is 64. If you divide this one by 2, you get this one, which is 32. If you divide this one by 2, you get 16. If you divide this one by 2, you get 8. If you divide this one by 2, you get 4. Let's count. T1, T2, T3, T4, T5, and T6. So if we sum all of them, we're going to get this one. So let's see. 8 plus 4 is 12. 12 plus 2 is 14. 14 plus 6 is 14 plus 6 is 20. 20 plus 8 is 28. 28 plus 4 is 32. So you add 2 and carry 3. 3 plus 2 is 5. 5 plus 6, 11. 10 plus 1 is 15. You carry 1. So 1 plus 1 is 2. So proved. The next segment, the next one we have is sum to infinity. Sum to infinity. Sum to infinity of a GP. Sum to infinity of a GP. So it is given by A all over 1 minus R, where R less than 1. So for sum to infinity to occur in a geometric progression, the common ratio must be less than 1. Why must the common ratio be less than 1? Because from here, Sn equals to A into 1 minus R to the power n all over 1 minus R. When n approach infinity, then Sn will approach sum to infinity. Then R to the power n will be approaching R to the power infinity. Then this guy now becomes sum to infinity will be equals to A into 1 minus R to the power infinity all over 1 minus R. But anything raised to the power infinity is 0. So this will give us A into 1 minus 0 all over 1 minus R. So therefore, sum to infinity will be A all over that. This will be A into 1 minus 0 is 1 all over 1 minus R. So sum to infinity. So this is it, which is the same as this one. So, and for this to occur, our common ratio is less than 1. So that's why the condition here will also be here. So for sum to infinity to occur in a geometric progression, the common ratio must be less than 1. So now let's wrap up by taking an example that has to do with this. Find the sum to infinity. Find the sum to infinity of the GP. 9 over 10, 9 over 10 all square, 9 over 10 raised to the power 3, and so. So here, I think here the first term is equals to 1, and the common ratio is 9 over 10. And 9 divided by 10 will be 0.9. And we are looking for the sum to infinity. I will know that sum to infinity will be A all over 1 minus R. And A is 1. 1 minus R. R is 0.9. So this will give us 1 all over 1 minus 0.9 will be 0.1. And the answer will be 10. So therefore, sum to infinity is equals to what? 10. So that's the answer. Sum to infinity is 10. Please, as we continue, endeavor to what? To subscribe to my channel. In the evening, we are still going to see more of maybe mathematics, physics, all these science calculations. So that when I will draft the event program, you will be notified. So the only way for you to be notified is that you will click on the what? Subscription button. And I also like you to what? Maybe watch my videos. Yes, like my videos, comment my videos, and also you share it. As you do so, may you be blessed. Let me give some few seconds for you to go through this. Then let's wrap up. Then, if it's for maybe students for in the university, they always ask them at times to prove that the sum of the first n term of an AP is given. If you are doing something like further mathematics, or maybe you're in the university, it's maybe year one, that has to do with all these general mathematics courses. They may even ask you to prove that the sum of the first n term of an AP is given as n over 2 into 2a plus bracket n minus 1d. Or you should prove that the sum of the first n term of a GP, Sn, is equals to maybe a into r to the power n minus 1 all over r minus 1 for the common ratio greater than 1. Or Sn equals to a into 1 minus r to the power n all over 1 minus r for common ratio less than 1. So when we'll do that too now, then we'll wrap up for now. So when our next meeting again will be maybe late in the evening, maybe around 7 or 8 as the case may be. But when you click on the subscribe button, once when I write the event, you'll be notified. So let's look at it. Don't come here. So let's take one of the questions. So prove that the sum of the first nth terms of an AP is given by Sn equals to n over 2 into 2a plus bracket n minus 1d. Yes, this is the question. They say you should, yes. Prove that the sum of the first nth terms of an AP is given by this, where a is the first term, d is the common difference, n is the number of our terms. So let's see. So, proof. Okay, so consider the arithmetic progression. Consider the AP. A. The next one, you want to get the next one. This is the first term. But to get the next one, I'll add the common difference. That's a plus d. The next one, a plus 2d, a plus 3d, and so on and so forth. T, I'll get the last one. The last one will be what? L. L is the last term. If I want to get the second to the last term, I'll subtract d from here. That will be L minus d. I want to get the next one, I'll subtract another d here. That will be L minus d minus d. That will be L minus 2d. It continues like that. So this is the first term, a plus d. A plus d, this is a plus, so a plus d will give us a plus 2d. If you add another d, a plus 3d, it continues like that. Having this one, L minus 2d. If I add another d, it will be L minus d, which is this one. If I add another d, it will be L, the last term, which is this one. So this is a sequence. Now I want to make it to be a series. What is a series? Series are terms in a sequence that have been added up together. So look at it. So sum of the first n term will be a plus d plus this one, a plus 2d plus a plus 3d plus this ellipsis, plus this one, L minus 2D plus L minus D plus L. So I'll label this one equation 1. That one is equation 1. Then I'll sum it again. I will now start from the last shall be the first, and the first shall be the last. So I'll start from here. This is L. I'll bring this one, L minus D. I'll bring this one, L minus 2D. After that, there is dash. 1, 2, 3. 1, 2, 3. So there is dash here. This is it. Then I'll go to this one. A plus 3D. Then here, A plus 2D. I'll bring this one. Plus. This is plus A plus D. Then I bring this one. Plus A. This is equation 2. So equation 1 plus equation 2. I will now add up the two equations together. So Sn plus Sn will give me 2Sn. This will be what? A plus L. Adding this with this will cancel this. So this will be A plus L. 2D minus 2D is 0. So I'm left with this one. A plus L. Then here, this dash shows that there is minus D minus 2D. There is a minus 2D on this ellipsis. That will take care of this one. That's this minus D minus 2D. There's a minus 3D here. So it will be this dash 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 means L minus 3D, which will cancel. So this will be yes, A plus L. A plus L. So life continues. Yes, it continues. So you come here also. This plus this will cancel this. I'm left L. So L plus A is the same as A plus L because addition is commutative. So that will be plus A plus L. This cancel this. A plus L. L plus A will be A plus L. So this will give us 1A plus L. That will be this plus this will be 2 into A plus L plus this 3 into A plus L plus this 4 into A plus L. Then with this dash dash and so on 5A into A plus L, 6 into A plus up to what? Up to N into A plus L because of this ellipsis. So there are many, there are endless number where N belongs to the set of positive integers. So that will be N into A plus L. So from here, Sn will be equals to N over 2 into A plus L. But L is A plus bracket N minus 1D. So this will give us sum of the first N to be N over 2 into A. This is A plus L. This L, this L, this is this one. So in the place of L, this is what we're going to write. So this will be A plus bracket N minus 1D. Then Sn will be equals to N over 2 into 1A plus 1A will be 2A. They bring down this one, N minus 1D. That's it. So it is proved. So that's it.